Welcome to lecture 2 on unit 4, which is related to the PROMs. Already we have discussed regarding the unit objectives, and we have discussed types of PLDs, that is fundamental PLDs and complex PLDs in the previous lecture. Now we are going to discuss in detail about first PROMs. PROMs means programmable read-only memory. If you revise, it has fixed AND array and programmable connections for OR gates. And how do we implement Boolean functions using PROMs? And in the previous lecture, we have already seen the difference between PROMs, PAL and PLE. And in this lecture, we will be discussing in detail the design of PROMs, which consists of fixed AND array and programmable OR array. Fixed AND array is also referred as a decoder, because a decoder internally consists of array of AND gates which produces the minterms. This is very, very important. I repeat, decoder generates AND terms for which you require AND gates, and those are minterms. So what actually PROM? First you need to know what is the use of the PROM. ROM is a memory which is used to store the permanent data, right? Even though the power is cut off, the data or whatever the memory you are storing, that is not a volatile. It would be stored for more time, right? Even though the power is cut off. The block diagram of ROM is shown below, right? How many address inputs it has? It has k address inputs. And how many outputs it has? It has n outputs. And what is the size of the ROM? Is 2 power k into n. This is very, very important, right? If it has k input address and n outputs, the size of the ROM is 2 power k cross n. The number of words in a ROM is determined from the fact that k address inputs, right? So how many words it can store? It can store 2 power k words. That means to access 2 power k words, you need 2 power k addresses, right? So this is very, very important. So what I mean to tell is, what is the input to ROM is the address, and what is an output of ROM is the data. That is a function of the ROM, right? If you give an address, it will produce the data at that particular address. That is the significance of ROM. So whenever you are giving the address, in that address, what is the data stored? That would be produced at the output. So that's why output is a data, input is an address. And what is the size of the ROM? This is very, very important. If it has k inputs, n outputs, the size of the ROM is not k into n, but it is 2 power k into n. This is important. And how do we construct a ROM? ROM consists of, in the first stage, it consists of a decoder followed by OR gates. This is the first one. And the output of decoder will be given as an input to OR gates, right? So a 2 power k into n ROM will have internally k into 2 power k decoder and n OR gates. I repeat, if the size of the ROM is 2 power k into n, then what would be the size of the decoder? K into 2 power k. And how many OR gates does it consist? N OR gates. That means the number of outputs of a ROM is equal to number of OR gates that are being used, right? And what is the size of the decoder? It is k into 2 power k, right? So this represents the size of the decoder, and this represents the number of OR gates required to construct a PROM. So PROM internally consists of a decoder and OR gates. What is the size of the decoder? It depends on this k parameter. And how many OR gates does it has? It depends on this n parameter. This is very, very important. Then, for example, what would be the internal architecture of 32 cross 8 PROM? So this can be represented as 2 power 5. 2 power 5. And PROM, the first stage, it consists of a decoder, right? So what is the size of the decoder? 5 into 2 power 5, that is 32. So this 32 represents the outputs. How many outputs does a decoder has? 32 outputs. If it has 32 outputs, how many inputs should it have? Definitely 5, because 2 power 5 is 32. So this 32 represents number of outputs of a decoder. 0 to 31, total 32. And if it has 32 outputs, definitely it should have 5 inputs. So that's why it is referred as 5 cross 32 decoder. So this is the first stage of the PROM. And all the outputs of decoder would be connected to OR gates. Right? So there is a single line to this particular OR gate. That means, going back to the specification of PROM, it has programmable OR gate connections. That means programmable means wherever the connection is required, we do connect the connections. Right? And how many OR gates does this PROM consist? 8, isn't it? So this 8 represents the number of OR gates that are required for PROM. So here there are 8 OR gates, and those outputs are A0 to A7, right? And as we have, according to the concept of PROM, if you are giving addresses, the value at that address would be produced at the output, or the data at that particular address would be produced at the output. So how it produces the output, right? So that we'll be seeing in the next slide, right? So now, as per this size of the ROM, 32 represents the number of outputs of a decoder, 8 represents the number of OR gates, and each OR gate has a single output. So totally it is a 32 cross 8 PROM. Right? So don't think that it is a 5 cross 8 PROM. 5 is an input to the decoder, right? But to represent the size of the PROM, we write outputs of a decoder, but not the inputs. That is 32. Then, coming to the next slide, each OR gate must consider as having 32 inputs. And the intersection between two lines is sometimes called a crosspoint. So we will be seeing that through an example. And in the table, if there is a 0, no connection. 1 means there is a connection. So this you will understand when you see the table. So this is the table, right? And this is a ROM truth table. According to truth table, now we will be constructing the ROM. So what is the truth table? It consists of 5 inputs, I0 to I4, and we have to think that this is an address, right? And at this address, it should produce this particular data. That means you are storing this particular data at this particular address. So how will we be writing this? or how we'll be designing a PROM. It's very simple. So 5 inputs which are given to a decoder, it will produce 32 outputs, and these are the 32 outputs 0, 1, 2, 3, and the 4 to 27 is not represented for the space conservations, and 28 to 31 are the last 4 outputs. Now A7 is an output, and how many outputs are there? A0 to A7, 8 outputs. So definitely you require 8 OR gates. Those outputs are A0, A1 up to A7. Now, considering this single column, for which input combination of a decoder, A7 is 1. So when inputs are all zeros, what is its decimal equivalent? 0. Right? So this particular output is connected to OR gate. That means we will be indicating that with a cross mark, isn't it? Because for this combination, A7 is 1. What is the decimal equivalent of 5 zeros? 0. So for this, we will be connecting a cross mark. Next, if you see the next combination, it is 0 for the combination of 4 zeros 1. What is the decimal equivalent? It is a 1. So if there is a 0, no connection. If there is a 1, you need to indicate with a connection. So the next combination is 00010, whose decimal equivalent is 2. So for this output, you need to indicate with a cross mark because the output is 1. Similarly for 00011. Like this, how many ones are there in this column? 1, 2, 3, 4. So there are 4 cross marks. Right? This is how we will be indicating with a cross mark when if there is a logic 1 in the table. If there is logic 0, no need of cross mark. This is what the programmability, right? So this cross mark is nothing but a fuses. If there is a connection, we close the fuse here. If there is a 0, we will be opening the fuse. Right? So this is how we indicate the programmable connections. Similarly, you repeat the steps for the remaining outputs like A0 to A6. Right? So now I think you have understood, right? First stage decoder, which internally consists of AND gates whose connections are fixed. Second stage, OR gates inputs are programmable. So this clarifies what is a PROM. Right? Again, the same thing is shown in this. Right? Same thing is shown. So if there is a cross mark, that means there is a connection which indicates a logic 1. Right? And this is what the outcome of the lecture. After completion of the lecture, students will be able to realize the functions using PROM, and now you can easily design a PROM using decoder and OR gates. Right? Now going back once again, if I change, if I ask you the question, design a 16 cross 5 PROM. 16 cross 5 PROM. 16 means outputs of a decoder. Outputs are 16 means input must be 4 because 2 power 4 is 16. So inputs must be 4, and 16 cross 5. 5 means the number of OR gates should be 5. Right? So these are the concept of designing of PROM. And feel free to post the queries in the group. Thank you.